Hey guys, we are here to learn the control system of electrical engineering for various electrical exam like GATE. GATE consists 18 to 12 mark for control system. ESE pre it consists 18 to 25 marks and for main exam it consists 60 to 84 marks. Control system also include in many exam like ISRO, DRDO and so many PSUs. The syllabus for control system is the basic. First chapter is the basic, second chapter is the block diagram, third chapter is the signal flow graph, fourth chapter is Raoult-Harvey's method. It is also known as RH method. Time response analysis, root locus, Bode plot, polar plot, Nyquist plot, state space analysis, and last is the compensator and controllers. The textbooks we use for the control system is Control System by Nagarath and Gopal. It is a standard book. Control System by Nagur Kani, easy language and simple to understand. And for numerical, Control System by Anand Kumar. To enter the control system, we must know the transfer function. By definition, the transfer function is the ratio of Laplace transform of output to the Laplace transform of input at initial condition 0. Here initial condition 0 indicate the transfer function is applicable only for the linear systems. For nonlinear system analysis, we use the state space. Transfer function, the ratio of Laplace transform of output to the Laplace transform of input. For impulse system, the transfer function is Laplace transform of impulse output to the Laplace transform of impulse input. We know the Laplace transform of output is also known as impulse response. From that we get the equation for the transfer function is transfer function equals to Laplace transform of impulse response to Laplace transform of impulse input. Laplace transform of impulse input is the 1. The value of Laplace transform of impulse input is 1. Therefore, we get the transfer function equals to Laplace transform of impulse response. From that, we obtain the impulse response. Impulse response equals to inverse Laplace transform of transfer function. Now we move to the questions. The impulse response of the system is e to the power minus t minus e to the power minus 2t ut. The transfer function of the system is given. From this question, impulse response equals to e to the power minus t minus e to the power minus 2t ut. The transfer function equals to a Laplace transform of impulse response. Put the impulse response in the equation. We get the equation transfer function equals to Laplace transform of e to the power minus t minus e to the power minus 2t ut. The Laplace transform of e to the power minus t is 1 divided by s plus 1 and Laplace transform of u to the power minus 2t is 1 divided by s plus 2. By cross multiplication, we get the equation s plus 2 minus s minus 1 divided by s plus 1 into s plus 2. Finally, we get the transfer function 1 divided by s plus 1 into s plus 2. It is the final answer. From that, we get the negative poles minus 1 and minus 2 and therefore the system is the stable system. Second question is the impulse response of the system shown below. For the given system, the impulse response to find out the transfer function is equal to Laplace transform of output divided by Laplace transform of input. We get the transfer function 1 divided by s into s plus 1. We apply the partial derivative a divided by s plus b divided by s plus 1 and from that we get the value for a and b. A value is 1 and b value is minus 1. The put in the above equation and we get the transfer function 1 divided by s minus 1 divided by s plus 1. Impulse response is the Laplace inverse of transfer function. Put the transfer function in this equation, we get the impulse response. Laplace inverse of 1 by s is 1 and Laplace inverse of 1 divided by s plus 1 is my e to the power minus t, and from that we get the impulse response 1 minus e to the power minus t. Now third question. System of transfer function is given 2s plus 5 divided by s plus 5 into s plus 4. The DC gain of the system is. We find the DC gain. The solution for this, for DC the frequency is 0. From that we get the angular frequency also 0, and from that we get the s value is 0. Put the s value is 0 in the above equation and we get the equation 5 divided by 5 into 4, that is 1 by 4 and 0.25. We get the DC gain for the above system is 0.25. Thank you for today. Next lecture we start the control system.